Any questions? No? So the exam is Friday. You'll come on the same link as you are today, same time. Only you'll have your cameras on so I can see you. If your camera doesn't work on your computer, then make sure to use, you could hook up Zoom on your phone and then you can still use your computer for the tests and things like that. Any questions? Today, there'll be no office hours because my other course, there was 4 students who couldn't take it and they're taking it during the office hour. So today there won't be any office hours, but if you do need to meet with me, let me know and we'll find another time that we can meet. The exam, as we said, is this Friday, which is, excuse me, 17th. Any questions? If you've looked at the weekly checklist, a lot of things were put in. I forget where I put it at though. Did I put it on the? I might have put it down here. So review for exam. Here's the review problems. Here's the formula sheet. Humanized values, conversions that you need to know. So everything you need under review. Formulas for review. It's also kind of like an outline, like what you need to know. If you want to put little notes next to it that you use to remember it, you can. But I think for the most part, like these 3 students are pretty good with that. But if you want to write little notes in there, you can. When we're doing certain parts that remind you of what is what. Significant figures, the rules are here. That way, if there's one you're not sure of. I think the biggest thing is the zeros after or before is what confuses students. And when we do them, we'll talk about them, but they're here. Convert unit parts. I don't know if there's a note you want to put or about bar graph and pie chart. You'll have to graph. I don't know if it'll be both or at least one of them and read one. Conversions for Celsius, Kelvin, and Fahrenheit. Net flow is inflow minus outflow. To draw a system diagram if there's notes you want to write. What I did was the practice problems. As I was doing them, I wrote what I needed or like a little note. This problem's going to be on there. Is there anything you want to write? Residence time is the level of stock and the flow rate. Oh yeah. But just different notes. Now I noticed your book has 1 tone is 1 cubic meter. Somehow I don't know what this was for, but that shouldn't be there. I will update it tonight, but I noticed it this morning. It's actually 1.1 cubic meter if you're looking at it online, but your book was just rounding that to a 1. So I'm fine with either one of them. If you have to convert one tone to 1 cubic meter, they're the exact same. They're almost the same. So for an approximation, it's fine to assume them equal. We're talking about numbers that are so large or so small, this 1/10 isn't going to affect it. Efficiency, rate of heat loss, and R value. I think that's it. 2.4 is not on the test. So it's, we didn't cover enough of it, and I didn't want to cover something else this week. I wanted to just review. So it's chapter 1, chapter 2, except 2.4. These we've talked about, and these sheets, you can print them and have them with you during the test. So these conversions, you can have them with you. And like the ones that weren't on there that I added on here, let me see where's one at. 1 watt is 683 lumens. 1 tone is 1 cubic meter. 1 joule. I had this open when I was doing the test. So if you want to move these to this, you can just write them in there, and that way then all your units are together. You can do that. But yeah, this is something I would print. You can have it open on your screen, but then if you're flipping back and forth to so many different things, I think it's easier to have it written. Up to you though. If I ask you to humanize something, I gave you some, and that's what I want you to use. This would be another one if you wanted to put it on your formulas, conversions that you need to know, you could put it there. 1 barrel is approximately 42 gallons. So if you're asked to humanize, these are the ones you want to use. Any questions? Okay. The outline has 25 problems. So I think if we get at least 7 a day, we'll cover them all. Some of them go a lot faster than others, but you will not see anything that you don't see on these 25 problems. So if there's problems not in there, then it's not on it. Identify the number part and the unit part. Remember, the unit part's the measurement, like 5 miles, 5's the number, miles is the unit. Now, on some of these, I also asked you to express, it asks if it's in human terms. But then I said like scientific notation, significant digits on some of them, so we could practice. Okay, so the distance around the equator is 24,000 miles. Number part. So the first one, 24,000 is the number. Excuse me, miles is the unit. Would that be in human terms? I guess that's something you could write. I don't think I put that, but human terms should be a number between 0.01 and 100 if possible. And you want to try and keep it small so it's easier to visualize. It also, I mean, when we think about miles, I can kind of visualize it because my house to the traffic light is approximately a mile. So I have more of a visualization, but it's not one that's very common, and 24,000 is very large. So this is not in human terms. It's just way too large. Scientific notation. Remember, you have to pick a number between 1 and 10, which would be here, 2.4. And then decimals here, we need to move 1, 2, 3, 4. So it's a 4, and it's a positive 4 because 2.4 needs to get bigger when I multiply. So this would be your scientific notation. Significant figures. It's 2. The zeros after do not count. Another thing, when you put it into scientific notation, you can see how many there are. If I look at this one, trailing zeros in a whole number with no decimal are not significant. There was no decimal at the end. Now, if I put a decimal here, then it makes it significant. There'd be 3 here. So this only has 2 because there was no decimal. Any questions on that? If there was a decimal put here, then it would be 1, 2, 3, 4, 5. Any questions? The lower 48 states receive a total of 1,400 cubic miles of rainfall per year. So 1,400 is the number part. This is the unit part. Is it in human terms? Nope. Any questions? The next one is putting it in human terms. Each year, the 48 states receive enough rainfall to cover them in a depth of about 2.5 feet. So you're thinking of all the states with 2.5 feet of rain. That's a lot. But it's a lot easier to visualize than 1,400 cubic miles. So the part C then, 2.5 is the number part. Feet is the units. And yes, it's in human terms. It's a number between 0.01 and 100. And you can visualize 2.5 feet, almost a yard. Any questions on that? Penn State University Park produced about 15,000 tons of waste in 2012. Number part, 15,000. Tons is the units. Would that be in human terms? Anyone? You can type it in the chat.
No.
Yep. There's none. I mean, it's not human. I think the next one puts it in human terms. Oh, no, I must have took that one out. My height is approximately 0.0011. Very small. Nautical miles. Is that in human terms? It's a little too small. And nautical miles is a little too big. No. Convert it to scientific notation. And how many significant figures? Again, we need to write a number between 1 and 10. So that means we're moving our decimal here. 1.1 times 10. 1, 2, 3. We need to move 3 decimal places. And this number is going to get smaller, so it needs to be a -3. Any questions on that?
For human terms, it has to be between 1 and 10 or 0.1 and 10.
0.01.
Okay.
I'd say 0.01 to 100. Now there are cases where you could say, like if it said there was 120 feet, you could say that that's human terms. I mean, if it goes a little bigger or a little smaller, you could, but to try and visualize this number with nautical miles, it's hard to visualize actually if it is really small, because nautical miles, a mile is long. The ones on the test, I don't know how much, there shouldn't be very many, but the ones on the test would be definitely noticeable, like the 24,000 or even larger. I won't make it close, so then you have to think about it. Oh, significant figures. Now we know there's either 2 or 4. So if we look at this rule, which one was it? I just saw it. This one. Leading zeros are not significant. They're neither more than the placeholders. The number 0.54 has 2 significant digits, but so does this one, 0.0032. 2 significant figures. So if it's before the number, they don't count. So this one would be 2 significant digits again. Any questions on that? Two more. My height is approximately 6 feet. 6 is the number part. Feet is the unit. Is it in human terms? Yeah, you can visualize 6 feet. Worldwide consumption of jet fuel is roughly 5 million. $5 million is my number. Barrels is my unit. This number is huge, so it's definitely not in human terms. So any questions on that? I will probably put that question into a different, like a question like this, and then just say, is this in human terms? Or, what's the number, what's the units, things like that, just in one of the problems. Convert worldwide consumption 5 million barrels each day, so per day, to liters per minute. And 1 barrel is 42 gallons. But of course, that's on your that formula sheet. So, we need to get to liters though, but we know 1 barrel is 42 gallons. Now you have to decide if you're going to put barrels on top or bottom. This barrel's on top. To cancel it, I need it on the bottom. So 1 barrel. 42 gallons. One gallon, if you look at your formula sheet, we need to get to liters. And 1 gallon is 3.785 liters. We need to put the gallon on the bottom, so barrels canceled, gallons canceled. 3.785 liters. Now I have liters. I need to get days to minutes. I know that 1 day, and this day is on the bottom, so I need a day on the top to cancel. 1 day is 24 hours. And 1 hour is 60 minutes. Now I have liters per minute. Now, if you want to do them in 2 separate sets of proportions, that's fine also, but you have to show your work. You can't just go on the internet and Google it. Any questions on that? Any questions? How many people are needed to hold hands around the world if the equator is approximately 24,000 miles? What do we need to estimate if we wanted to solve this? Anyone?
How like long people's arms are if they're like held out.
Arm span. Anyone have an estimate for arm span? on average, your arm span is your height. What do you think the average height of a person is?
6 feet.
6 feet, okay. And we wanted to find out how many people, so each person arm span is 6 foot, so 6 foot per person. This is miles, this is feet, we need to convert this to feet. Miles to feet is on that formula sheet, it's one that you should have memorized though. 1,000 miles, and we want this mile in the bottom so that they'll cancel. Does anyone know what the feet is? 5,280 feet. And we're saying one person is 6 feet arm span. So if we calculate it, it'll tell us how many people. So 21 million people. Is there enough people in the United States that everyone could hold hands? That we'd have enough, I guess is what I mean. If we need 21 million and we took them all from the United States, do we have enough people in the United States? That's one of the ones that's on that formula sheet. It's a number you should know. It's around 330 million. So we have plenty of people. So you will have to compare it to something that you should know. Oh, here it is. Somewhere around 336 million. Now, if you go 300 million, 330 million, 340 million, somewhere in there. And then 7.9 billion, 8 billion. I think I looked it up. It was 7.899 billion right now, something like that. So you can round these, but they are values you should know. Any questions on that one? I think that's all it asks. But make sure when you're estimating something like the arm span that you put what your thought was. And there's no wrong, well, if you said a foot, it'd be a wrong answer. Okay, so Penn State University Park produced about 15,000 tons of solid waste in 2012. Convert this to human terms. So if you're converting to human terms, you want to use these. Now, notice we're in pounds. All the weights are in pounds. So we need to get tons to pounds. We know from our formula sheet that 1 ton is approximately 2,000 pounds. Then we can pick one of these. Now, the elephants, depending on what elephant, it went from 8,000 to 15,000. It's up to you what you would want to choose. The blue whale's 325. What do we have here? 15,000. So this is definitely too big. We wouldn't use that. This is too small, 7 pounds. So we'd have to use the 15 between these two. I'm gonna go with the largest elephant and the 15,000. Wait, that's what it was, wasn't it? Yeah. Okay, so that's kind of cool to look at, the 15,000 pounds. If we use that one, it should divide evenly. 15,000 pounds is one elephant. Of course, it's the largest elephant and it's a male. So tons cancel, pounds cancel, even the 15,000 cancels if you wanted. 2,000 elephants. Since we are multiplying this, you might be able to use the blue whale. If we multiply this and find the pounds first. One, two, three, 4, 5, 6. You could. So if you use the elephant, you'd have this one. Also remember when you're rounding. So you could do 2,000 elephants or 92 blue whale. I forgot we were converting first. I would accept either one, even though this isn't in your smaller version, under 100. I would still accept that. So either one. Any questions on that? One decade should be 10. Did I put 19? This should be 10. My keyboard is my mouse pad and sometimes things get messed up, but this should be a 10. Thank you for catching that. I will go on and fix it after, but. 1, 2, 3, 4, number 5. What is 4 million millimeters in miles? I know feet to miles. I know meters to feet. So I could go millimeters to meters. A meter is almost a yardstick. It's a little bit longer. It's 3.3 feet instead of 3 feet. So I could convert, that's how probably what I would do. Milli is 1,000. 1,000 millimeters is a meter. I put millimeters on the bottom so they would cancel. 1 meter is 3.3 feet. That's on the formula sheet. Feet to miles, 5,280 feet is 1 mile. I put that on the bottom so the feet would cancel, the meters cancel, I have miles. If you want to make your numbers a little bit smaller when you have zeros, these 3 zeros can cancel with these 3. Because 3 on the top, 3 on the bottom. Then I just have the 4,000 to work with. Times 3.3 divided by the 5280. 2.5. So 4 million millimeters is 2.5 miles. This would be humanizing because you're taking something, this is a huge number with a small measurement, and you're making it into something you can understand more. Any questions on that one? Number 6. Definitely see something like this on the test. The daytime surface of Mercury is 700 Kelvin. Express this temperature in both Celsius and Fahrenheit. On the test, you'll have to compare it with another one also. I thought I changed it, but I must not. Express this temperature in Celsius. So we would use our formulas. Celsius, there's these two depending on what you're given. We're given Kelvin. Go ahead and find Fahrenheit. Fahrenheit would be this one given. Yeah, I would go with what was given. So it's 9/5 times 700 minus 460. Any questions on finding them? If we know that Venus's surface area is 460 degrees Celsius, and we wanted to see which one was hotter, even though Mercury is closer to the sun, its surface area is not as high as Venus because Mercury is so much smaller. But if you were going to compare them, you can't look at this. You need to make them the same unit. So either make this Kelvin or this one Celsius, and then you can compare them. Mercury's definitely a lower, it's still a high temperature, but it's lower than Venus. And you would just explain that. the main thing I want to make sure is you know that you need to have them in the same units before you try and compare them. Any questions on that one? So you'll definitely see something like that. Number 7. The American Dental Association recommends that you brush your teeth for 2 minutes twice a day. So 2 minutes 2 times. Is that around a day a year that you'll spend brushing your teeth? So if you follow what they say, 2 minutes twice a day, in a year, will you have brushed your teeth for an entire day? I kind of like that problem. So I would start with 2 minutes 2 times a day, get it to a year and see how much I'm spending. So if I do 2 minutes twice a day, how many minutes am I doing in a day?
4.
So I'm doing 4 minutes in one day. And we want to know years. So I would convert days to years and minutes to days. Because we want days per year. It's up to you which way you want to convert. If you want to do minutes first, we know there's 60 minutes in 1 hour. Now you could stop there if you wanted. So 4 minutes, there's 60 minutes in an hour. Now, if I get rid of the days, I know there's 365 days in 1 year. So my days canceled, and this would be hours per year. So if I multiply that out, 4 times 365 divided by 60. $24.3 hours a year. 24 hours is a day. So yes, they are the same. If you brush your teeth for 4 minutes in a day, at the end of the year, you will have brushed your teeth for 24 hours or 1 day. So you could have went there, or you could have went further, one more multiplication, and changed this hour. 24 hours is 1 day. And then you would have gotten approximately 1. Any questions on that? So it's up to you. You could have stopped at the 24 and then said there's 24 hours in a day. So yes, you are brushing your teeth in a year's time for a whole day. Any questions on that? And this is just practicing. I'd probably put it in a problem. And there are some, well, we did some at the beginning too. But convert to decimal form. So if we have 1.5 times 10 to the 4th, this is a positive 4, so this number is going to get larger. This decimal is gonna move 1, 2, 3, 4. So it'd be 15,000. The other value, 2.65 times 10 to the negative 4. This number needs to get smaller because it's a negative. You're going to take away units. 1, 2, 3, 4. So the negative exponent makes it smaller. Positive exponent makes the number larger. Any questions on that? Number 9. Assume that 25 million, 250 million cars on the road in the United States. Each car gets 25 miles per gallon and drives 10,000 miles per year. 20 pounds of CO2 from each gallon of gas. And we want to know how many tons of carbon dioxide are emitted by these vehicles over 1 year. We know that there's this many cars. There's a few ways you could go about it. I went with the miles next because each car drives about 10,000 miles. Each year. And then gallons, 25 miles to the gallon. I want to get rid of this miles, so 25 miles is 1 gallon of gas. I know gallons, a gallon is 20 pounds of CO2. Gallons is in top, so I need on the bottom 1 gallon, 20 pounds CO2. So I can multiply this out. So I started with the number of cars and how many miles they drive in a year. And then I knew 25 miles was 1 gallon of gas. And 1 gallon of gas is 20 pounds of CO2. So this will give me the amount of CO2. Because everything canceled but the carbon dioxide, pounds of it. When you do these on your calculator, instead of a 10 for your scientific notation, it'll give you an E. That E is a 10. So that means 2 times 10 to the 12th. So that would be pounds, but if we read the problem again, I think it asks for tons. Oh, no, it didn't. Oh, yeah, it did. How many tons? So we have to convert this to tons. And we know 20 pounds is 1 ton. Pounds needs to be in the, I said 20, but it's 2,000. 2,000 pounds needs to be in the denominator because pounds needs to cancel. Then we'll have tons of CO2. So we take that answer, divide by 2,000. One, two, 6, 7, 8, 9. So we're getting 10 to the 9th. When this is a 1, it doesn't have to show. You can just put 10 to the 9th. Any questions on that? Okay, if you do not have any questions, I will see you tomorrow.
Thank you.
You're welcome. Have a nice day.